Hello, Marcus. We are doing notes for 6-3 today, but we just turned in 6-2, so you will have to do that. Make sure you remember to turn this bell curve sheet with the baby on the back. We are doing 6-3 notes. Here we go. This is what 6-3 is in a nutshell. Okay? The majority of statistics, or the reason why we do statistics, is because we want to be lazy in a sense. Okay? So you have something going on over here. You have a population. Listen. You have a population. And then you have samples out of that population, okay? And a lot of times you'll pull like a ton of samples out of a population, and then you'll do the statistics with those samples, and then you will compare that data, right? They repeat studies all the time, like in research and development, okay? Like especially for pharmaceutical, like drugs. That's why drugs are recalled, okay? Because somebody will run a test, they'll say, yep, that drug works, it's good to go. And then somebody else will take another sample, they'll run that test again, and they will find out that something's wrong with that drug that's causing adverse side effects, and then they'll recall the drug. That's how that works, okay? So, like, it's not just a one and done. You don't just take one sample, get your data, and you're done. You have to sample again, and then sample again, and then sample again. That's why, like, there's so much money put into research and development. It's crazy, okay? What we're going to be doing today is this process. We're going to be taking samples out of a population, but on a very, very small scale, okay? Like we're selecting 2 numbers out of a group of like 4 numbers, okay? So we're doing this process, like imagine that this would be on a larger scale, okay? But we're doing it very small scale so we can do those calculations very quickly, okay? But just keep in mind that this would be on a bigger scale, all right? So here we go. When we're looking at stuff, they have kind of an intro example here. When samples of the same size are taken from a sample population, I'm going to go down to number 2. The mean of the sample is going to be very, very close to what the mean of the population is, okay? So we take samples in order to estimate what the average is. I don't know what the average is for the population because I don't want to have to do that for every single person, right, in the population. I want to be lazy. I want to just take a sample of them, right? I don't have access to data for the entire population probably. So I'm going to find the mean of the sample and say that that's pretty close to the mean of the population, okay? That's why we do this process, all right? Example 1, here we go. Consider repeating this process. If we roll a die 5 times, find the proportion of odd numbers, okay? If I roll a die 5 times, about half of the time it should show up to be odd, right? The proportion of odd equals 1/2. Now, if I'm rolling it 5 times, are you going to get half of those times to end up to be odd? No, because half of 5 doesn't happen. It's 2.5 rolls, okay? So let's go ahead. This is the theoretical probability, okay? In theory, what should happen is half the time it should be odd, but if I'm rolling it 5 times, that's not actually going to happen. All right, here we go. I'm going to roll it 5 times. This is actually what happens. This is the experimental. Actual, okay? Now, just showing you that when we calculate this stuff, it doesn't necessarily mean truth, right? 2, it's like what should happen, all right? That was a 2. This is a 1.
That was an awful roll.
That was an awful roll. Well, I'm trying not to roll it off the table. That was another 2. Okay? Go. 6. And? Girl? 3. Okay? How many odds? 2 out of 5, which is 40%, not 50%, okay? But again, we said that you can't get 50% of the time out of 5, right? The next time it could be an odd. I don't know. Who knows, okay? But in theory, this is what we're calculating. We're trying to calculate in theory what should happen, which doesn't necessarily always match the actual, but it's fine. What do we know about the behavior of all sample proportions that are generated as this process continues indefinitely? So, we said we could not find exactly 50% of 5, but if I did 6 numbers, or if I did 10 numbers, if I did 100 numbers, about what percent of them, these numbers should end up getting closer and closer to a 50-50 split. Shh, I'm going to say that again because you weren't listening.
Yeah, it's because
Okay?
Kelsey was distracting me.
I did 5 numbers, okay? And 5 numbers ended up with a stop. Boy, I'm taking that away from you if you do it again.
Boy.
Okay, 5 numbers. We could not get a 50-50 split. Listen. Shh. This is going to go longer if you don't listen. 5 numbers cannot result in a 50-50 split, okay? If I did 6 numbers, It might be a 50-50 split if I did 10 numbers or 100 numbers or 1,000 numbers. The more rolls that I do, the closer that's going to get to be a 50-50 split for odds and evens, right?
Exactly.
Like 100 might be a 48-52 split. 10 might be, whatever else. The more times I roll it, the closer it should get to a 50-50 split, what the actual is, right? That's how that works, okay? All right, good? Okay. We're going to write these down on our yellow sheet. Eventually, you guys better have that yellow sheet still. We're not going to do it today, but we're going to eventually write it down. You don't have to get that out. We have standard deviation. We have standard deviation here, and then we have variance here, okay? Standard deviation is this guy, variance is this guy, okay? We know that you just take the square root. Square root to get the standard deviation, yeah? The square root of the variance is the standard deviation. Shush, boys.
Girls.
The square root of the variance is the standard deviation, okay? We're going to be doing this process and finding the variance and standard deviation of our little samples that we select, okay? Here's the process. This is what your homework assignment is going to look like. We have a bunch of children in a room that are aged 4, 5, and 9, okay? Only aged 4, 5, and 9. Shush, be quiet. I don't need any comments, all right? 4, 5, 9. Those are just the ages of these children, all right? I'm going to only select 2. So my population is the room full of 4, 5, 9-year-olds. This is my population, okay? Because we're doing this on a small scale, okay? Typically there would be like more ages, whatever, but we're just going to assume just ages 4, 5, 9. That's my population. We're going to only select 2 children, okay? So, 2 children. Identify the list of possible samples and write them in the table below. If my population is only 4-year-olds, 5-year-olds, 9-year-olds, okay? Here's what could happen. I'm sampling 2 of those, right? I could get 2 4-year-olds, right? Like a 4-4 sample, okay? What else could happen?
4-5.
I could get, let's go 5-5 sample. Let's go 9-9 sample, okay? I could get 2 5-year-olds, 2 9-year-olds, okay? Then let's do the combinations.
3, 5.
I could get 8.
3, 10.
Is it 3 or 4?
3.
Okay, shush. She's doing something else. I could get a 4-5 combination. I could get a
5-4.
5-9 combination. 5-4 is the same thing as 4-5. I could get a 5 and a 9-year-old, or I could get a 4 and a 9-year-old, okay? Again, this would be on a very, very large scale. We would be sampling more than just 2, but we're doing just 2 for now to make it a lot easier, yeah? Okay, do we see how this works? Okay, we're finding the mean, which means we're finding the average, okay? And if I'm finding the average of 4 and 4, what's the average of 4 and 4? 4, what's the average of 5 and 5? 5, what's the average of 9 and 9? 9, what's the average of 4 and 5? 4.5. 5 and 9?
7.
You add them together. 5 and 9 is 14. Divided by 2 is 7. Yep. 4 and 9 is 6.5. Right? Okay, that's how that works. That's the mean, right? Okay, the median is the middle. The median is the middle number. Okay, if I'm taking the middle number of 4 and 4,
It's the same.
it's going to be 4.
It's the same.
The median and the mean will be the same because we're only selecting 2, right? So the middle number is the same as the average if we're only selecting 2, right? Does that make sense?
Yeah.
Okay, the mean and the median will be the same because we are only selecting 2. Okay, the range. What's range mean?
Small to big.
Small to big, okay? 0 is the range if I do 4 and 4. What's the range of 5 and 5?
0.
0, range of 9 and 9. 0, range of 4 and 5. 1, range of 5 and 9. 4, and range of 4 and 9 is 5.
How is it 4?
You're not on the.
Oh.
Okay, anyway. All right, now these 2, variance and standard deviation. Here we go.
Shit. Shoot.
Okay, boy.
I was doing the homework instead.
Oh, darn. Oh, darn. I don't feel bad for you. Okay. Variance and standard deviation. Blah, 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 blah. The sum of x minus mu squared over n. Okay, this is your standard deviation, or your variance, and then the standard deviation equals the square root of that number, right? Whatever we get for that, okay? All right, this is going to be a pain in the butt. This part is the pain in the butt part. This is the part that you need to pay attention to. Okay, we're gonna identify.
So
What is X?
X is the
Our number.
the-
It's whatever our number is, okay? What is mu?
average.
The average, okay? What is N? Capital N.
Rate.
Don't care.
Number.
Lowercase n.
Total number of not samples. Or samples.
No.
Is it total number of
Lowercase n is the number in the sample. Capital N is the
population?
number in the population.
What
Okay?
is the population? Wait. So
How many numbers do we have in the population?
3.
No.
3.
3. There are 3 different values in our population. So N, capital N for this case will be 3. Does that make sense? Okay, so here's how this works. Here's how this works. Ready? We're going to do variance. Listen, we're going to do variance of the first one. I'll show you how this works. Variance of the first one. Here we go.
It was.
Variance here. We do the sum of, we're doing x minus mu squared plus x minus mu squared. There are only 2 values in my sample. Okay? There are only 2 values in my sample. The sample numbers are 4 and 4. Okay? Therefore, we only have 2 numbers to add together. Okay? So, the first time, my first x is 2, my first x is 4, my second x is 4, because we're doing the 4, 4 sample, right? If we were doing 4 and 5, it would be 4 and 5, or 4 and 9, whatever, right?
0 squared plus
Okay.
0 squared is 2.
What is,
Can you zoom out a little bit?
2 over
kinda,
2.
maybe? What's the average for that first line? 4, okay? And 4. 4 minus 4 is 0. 0 squared is 0, plus 0 squared is 0. So I get 0 divided by 3, which is 0. So the variance of the first one is 0. The standard deviation is the square root of that. Hold on. No. The square root of 0 is 0. Now, here we go. Let's talk about what this means. Ready? This should make sense.
0, 0, 0.
Ah,
Wait.
this should make sense. Standard deviation is how much your sample is deviating. If I have 2 numbers that are exactly the same, how much is that deviating? It's not deviating at all, correct?
Yeah.
Not deviating at all. Okay, so the second one, when I do the 5, 5 or the 9, 9, how much are those deviating? None. So the variance and standard deviation are each going to be 0. Agreed? Okay.
Are the means always going to be the same for both? Like for the mu's? Both mu's are always going to be the same, right? Okay.
Yeah. Yeah. All right. Okay, so let's do the harder one. 4 and 5. All right, let me get rid of my stuff here.
4 is negative 1 squared. And then
4 and 5.
1 squared plus 1. What is negative 1 squared? Is that a thing? Why do I
Hold up.
why do I say I?
Okay, 4 and 5. We're doing the 4, 5 line, right? Okay, so my x's are 4. Whoop. Let me get rid. My x's are 4 and 5. Okay, what's the average?
So, 1, 2, 1/3. 2.
What's mu
2.
for that line?
6.
4.5. Shh. You girls gotta be quiet.
2/3.
Okay, 4 and 5 are my 2 numbers. My mu's are 4.5. We're still gonna divide by 3. 4 minus 4.5 is negative 0.5, and I'm gonna square that. Okay, 5 minus 4.5 is positive 0.5, and we're gonna square that.
3.
Okay.
6.5.
Yes, ma'am.
10 minus 6.
So did you just take?
Figure it out.
Okay, never mind.
Okay. All right, 0.5, negative 0.5 squared is 0.25. Okay, you 2 boys, go to the hall.
Wait.
You 2 boys, go to the hall.
Alright, let's go, Jake.
Go. 0.25, what's positive 0.5 squared?
I didn't know that was on. Why did you divide by 3? The standard deviation.
0.25, okay? If I take 0.25 and 0.25 and add them together,
Square root of
Because there's 3
2/3.
total numbers. You only have like the 4, 5, and 9, so it's only 3 numbers.
Yep, yep.
It's just a square root.
0.25 and 0.25 is 0.5 added together divided by 3. 0.5 divided by 3 is something. What is that number? 0.16 repeating, something like that. Okay, that's my variance, 0.16 repeating. Okay, then I take the square root of that to find the standard deviation.
So that is
The square root of 0.166666666, however many 6 you can type in.
Were you talking about the repeating sign?
Yeah. Yeah, why don't you? Okay, what'd you get for a standard deviation? Anybody? Point? It's gonna be a bigger number.
0.408248.
We'll go 0.40824,
I don't know.
so go 0.4082. We'll go 4 decimal places.
Just wait.
Okay,
Let me do this one.
good?
'cause this
I'm
is
gonna
probably
change
gonna
this
count.
0.16 to like 0.1667. How about that? We'll go 4 decimal places. How about that? Okay? All right, the next one. Let me get it set up, ready to go. Okay, when it says sum, that means you're adding them together, but we're only putting 2 numbers in, right? That's how this works. Okay, the next one that I'm doing now, we're doing 5 and 9. My x's are 5, and 9. What's the average? What's my mu? 7. Okay, so I'm doing 5 minus 7 and 9 minus 7. 5 minus 7 is negative 2 squared, and 9 minus 7 is positive 2 squared. Negative 2 squared is 4. Positive 2 squared is 4, so I'm doing 4 plus 4, which is 8, divided by 3.
See?
2.6 repeating.
Oh, yeah, you added me those.
So 2.6, we'll go 6667, because we'll go 4 decimal places. If you take the square root of that,
That's what I got for the bottom
Yeah,
one.
I don't think I did that one right.
I got 8.167.
okay, if you take the square root of 2.666 repeating,
See, I very well.
you get something
And then
for standard deviation.
Yep, that's my problem.
1.632? 1.632, one more. 9. 1.6329. Okay, you take the square root of the variance to get the standard deviation. Okay? All right, last time. We're going to do 4, what is it, 4 and 9?
Yeah.
4 and 9. 4 and 9.
So now we take.
I'm trying to erase, but not erase everything. Okay, so my numbers are 4 here and 9 here. We're still dividing by 3. What's the average? 6.5 and 6.5. Okay. All right, 4 minus 6.5 is negative 2.5. This is going to be positive 2.5. But if you square each one of those, you get 6.25, I believe. So 6.25 plus 6.25 divided by 3. 12.5 divided by 3.
2.0.
Whatever that is. 4.1667.
now an average.
Okay.
What does that mean?
Standard deviation is the square root of that.
The average of all these.
2.0412. Perfect. Okay, now, which one has the largest standard deviation?
7.49.
The last one, because is 4 and 9 the biggest deviation? Because that's the widest range, right? Okay, so now we're going to do the mean, median, mode, range, all that stuff. We're going to average them together. So find the average mean, the average median, the average range, average variance, average standard deviation. Got it?
You dumb dumb.
Okay, so add them up and divide by 6. Okay, even, this is the part that you guys screw up a lot. Even though I have 3 zeros here, you're not adding these and dividing by 3. You're adding them all and dividing by 6. Okay, so keep in mind that even though 3 of them are zeros, you still count those zeros in there and you add them up and you divide by 6. Okay,
The first 2 are 6.
the first 2 come out to be 6. Exactly. Perfect. Okay, so 6 here, 6 here. 1.6667 for the range. Okay. Variance, standard deviation. Let's do those. Okay. And then your standard deviation, add these up and divide by 6.
Okay, identify the list of possible samples. Do we do that in those bracket things? Like list them out?
Just, you don't have to do any of that stuff. It's all down below.
That's just
So
you
this
mean-
is
you
just
mean
giving
just-
you the
just
steps
do it
to
here.
do that. So just make sure you've done all the steps.
Are we doing
What'd you give it the last one? Sorry.
Determine which statistics. are
Point
good
6804.
Estimators.
Perfect. 0.6804. Okay, now
We have to do that at the end. Okay, so we're done. with
again,
this.
keep in mind that this would normally be on a larger scale. So we're sampling data Here we're only taking two numbers. We're sampling data. We would do the variance, standard deviation, all that good stuff. Now we're going to compare to what the actual population is because we can access that information. Our population only had 4 numbers in it. It was 4, 5, and 9, right?
4, you mean
So-
3 numbers?
What?
You mean 3 numbers?
3, what did I say? 4 numbers. The 3 numbers, 4, 5, and 9. We're going to find the mean, the median, the range, the variance, the standard deviation of the population. When it says sample, we're just going to copy these numbers down there, right? So the average for the sample was 6. The median for the sample was 6. The range for the sample was 1.6667. You see where I'm getting these numbers from? The variance was also 1.6667. I'm just copying those down. And then 0.6804, okay? Now, we have to actually calculate the mean, the median, the range, variance, standard deviation for the population, and then we're going to say, like, hey, are those close to one another? Was this a good thing to estimate using a sample? Okay, so we'll talk about what that means here in a second. The mean, if we're finding the average of these 3 numbers, 4, 5, 9. 4 plus 5 is 9, plus 9 is 18 divided by 3. 6. Okay, the median is not going to be the same as the mean, probably. What's the middle number here? Median means middle number. 5, okay? So in this case, they are not the same, right? Like they were for the sample, okay? Range from 4 to 9 is 5, okay? Range is way different for a sample, okay? All right, variance. Now, this is one more step further. Here when we did variance, we were taking these 2 and adding them together, right? Taking those 2 and adding them together. Now we have 3 of them to add together. This guy squared plus this guy squared plus this guy squared, right? Because there's 3 numbers in my population, right? Okay, what are we dividing by?
3.
Still 3, because N, capital N is still 3, right? Okay? All right, so here in each one of these, we're doing x minus mu, and x minus mu, and x minus mu. Got it? Okay, my first x is 4, my second x is 5, my third x is 9, but what's mu for each one of those? 6, right? So subtract 6, subtract 6, subtract 6. Mu is the mean of the population. Got it? Okay, 4 minus 6 is negative 2, and negative 2 squared is positive 4. So there's that one. 5 minus 6 is negative 1, and negative 1 squared is positive 1. 9 minus 6 is 3. 3 squared is 9. So I have 4 plus 1 plus 9 divided by 3. That's going to be my variance.
26.
I got 0.
Wait.
What?
I got 0.
4.6667?
Yes, I
Okay,
can.
perfect. 4.6667. Okay, that's my variance. All right, it's still not terrible of a formula. It looks really nasty, but you just have those 3 pieces added together. Okay, the standard deviation is the square root of that, which is something. 2.1602. You girls have to be quiet. 2.1602. Got it? Okay, now they're asking for which ones are good estimators. So the mean and the median. Okay, the mean was a good estimator. It was the same, right? So they say, yes, this is a good estimator for this sample. Is it always going to be a good estimator? Well, they set up at the top here, at the top of our notes, right here, that the mean of the sample is the same as the mean of the population. It's going to be about the same. It's going to be about the same. The mean of the sample should be about the mean of the population. Now, the median, the middle number. One was 5 and one was 6. I mean, they're close to each other, so in this case, it might be decent. So yes, but will it always be? Not always. Like if my numbers were spread further apart, my median might be way different. So not always. Okay? All right, what about range?
No.
Holy crap, no. That's like a really big difference. What about variance?
No.
No. What about standard deviation?
No.
No. Standard deviation is better than variance, but they're still not very good, right? Okay, do you see how that's a good estimator, not a good estimator? Okay, how do we make that estimator better?
More.
Sample more numbers, right? But we were doing it on a very small scale here. We're only sampling 2 out of 3 numbers, right? Imagine this being on a larger scale where you have like 100 numbers and you're sampling like 40 of them, right? Okay, so a lot worse of a process, but for the sake of doing the calculations, they only wanted us to sample 2, okay? All right,
What?
there you go. We're gonna skip. We'll skip the back page where it says biased and unbiased. Okay.
Oh, we need that for the top two.
What, 1 and 2, we need that.
No, we don't. It's okay.
We don't have to go
Let's do it
over it.
tomorrow.
Okay. Well, we'll just do it real quick. On the back side, they say that unbiased, which are generally good ones. These are saying generally good ones. This is the very back page. Generally good ones are proportion, which we didn't do. Like proportion was just like half of the time it's odds, okay? And mean, we said mean was good. They say variance is generally good. For our sample, it was not good, okay? But generally, in general, variance is usually pretty close for sample to population. Those two usually compare pretty close. So those are unbiased, okay? Things that are biased, which means not good, generally not good. We said that median for our sample that we just did was good, like it was pretty darn close. But in general, it's generally not good, okay? So it is considered to be biased, okay? So median, range, and standard deviation, we said that those were not good. But the median for our sample came out to be pretty darn close. In general, they're saying that it's usually biased. It usually does not come out to be the same, okay? So that's what they're asking for on 1 and 2. Good?
Yep.
Yeah? Okay, so 6-3, you've got like that stuff going on here. You have 3, 5, and 10, and you're taking samples of 2. So you have 3 and 3, 5 and 5, 10 and 10, 3 and 5, 5 and 10, 3 and 10. Those are like your numbers that go in for sample. You're doing exactly the same thing as what we did, okay? Again, we're doing this on a very, very small scale. We're only choosing 2 numbers out of 3 numbers. But if this was on a larger scale, like this was the calculations that they would be doing. Got it? Okay, there you go.
So for